Hello, this is going to be another quick tutorial. I've already made one in the past, but I'll see if I can't make one a little bit more complete and provide another example of how to run the Elegoo Mars printer. This will not be centered so much around the printer itself, but it will be centered around what software you're using and how to set up your files so that you can be prepared to slice them and create a file type that will be recognizable by the printer that you can print and hopefully print successfully. So what we're going to do today is an example on a 010B vanity mockup that is needed by one of our engineers down in Mexico. So I've already completed one of the files, but I'm going to go ahead and walk through mockup number 2. So what you're going to need from either something that you created or the engineer, designer, what have you, is an STL file. I sometimes request a step file as well because I know how to edit 3D files, and if you have some small changes that you need to make to what's being requested in order to make it more printable, that is sometimes faster than trying to go back and explain what you need. However, if you don't have that skill set, you don't need to really be concerned about asking for the step file. You need the STL file, which Windows recognizes as a 3D object. So don't just double click on it unless you know that it's tied to the specific software that you're using. I use multiple softwares, so it is not tied to what I'm using. Right here, move my face here a little bit. Right here is the Chitubox. This is the primary app that you're going to use to create your slice files out of the 3D STLs that you get. And this file or program here, Photon File Validator, is very useful to kind of check your work before you go ahead and try to make the print. So let's go ahead and get started with Chitubox. I will say, as another general reference, I found that some of these softwares will not run correctly on the default graphics processor inside of the computer. I don't remember what the error was that I was having, but basically to correct that, you just go anywhere for one of the program shortcuts, right click, select run with graphics processor, and then if you're having problems, choose whichever one is not chosen. And then if it works, then you can click here to change your default for that program. So once you have the program up and running, if this is the first time you've ever ran this program, the first thing you need to get into is the settings, right? And you're going to need to create a new printer, call it what it is. In this case, it's the Elegoo Mars, and then the machine parameters should be matching this for pixels dimensions and max XYZ capability dimensions, and the mirror style is LCD, not DLP or normal. At that point, you've got your printer set up. Now I have several different profiles set up for that printer because there are different parameters needed for different resins. In this case, I'm going to use what's called the ABS-like More base. If you look around at some of the 3D printed items that I have made in the past that are gray in color, that's typically the style of resin that I was using. Sometimes you will find, Ceratec Blue. So Ceratec Blue is kind of a translucent teal bluish kind of color. It is a little more tough and strong, but also brittle. So but if you have something that needs to be a little bit more structural, like you're testing out a nest block concept or something along those lines, you could go with the Ceratec Blue. Another common one that I use is the Ceratec Fast. Now let me see where I placed that. Ceratec Fast, there we are. So you'll notice as I selected these different profiles, nothing changed here. That's because the printer itself, there's nothing different from printer to printer. What does change, however, is you can change the resin density and cost. Now this doesn't impact the performance of the print, but what this will do is impact the summary that it gets you when you're done slicing the file. If you have the right density and the right cost placed into the this window, it will tell you how much volume of material that you're going to use, and it will tell you how many dollars in resin material it's going to cost to make that print. It's more just to kind of have that as a reference. This is the very most important parameters, and this is where you're going to see your changes. So in the Soraya Tech Fast, you'll see I've got an exposure time of 8 seconds per layer, and if I go to something like the ABS Like More, I'm still doing 8 seconds. Let's see, bottom layer count. Maybe my bottom layer counts are a little different. Let's go to something I know is different, Elegoo Black. So very dark resins take a lot more time. So I'm using almost twice the exposure time as the gray resin. There's really no reason to use the black other than you decided that you want your finished product to be black. Other than that, there's not really an advantage to going with this that takes a longer amount of time, just pure aesthetics. Like I said, one of the mostly the common one I use is this. Now, if you go into the recommended settings for these resins, you'll probably find that the recommended exposure times or bottom exposure times are slightly less time than what I have, and maybe even this bottom layers. That's because I have found over experimenting that adding a little bit more bottom layers and a little bit more bottom exposure time helps the process be a little bit more reliable. Getting into these parameters and tweaking them can be a whole different set of learning that you could do. It's not something, once I have it set up, that I generally tweak very much for this type of printing. There thankfully is actually very few parameters to mess around with. Infill, just leave it off, and anti-aliasing, I also leave it off. This I haven't messed with, but basically I think when you have some sharp edges from layer to layer, it tries to naturally smooth those edges out when it does the slice. Today we're going to try to use the ABS Like More base. So once you have your parameters and profiles saved and set up in here, you can, as you open this, I kind of wish they had a little pull down or a kind of in your face screen that showed you what resin you're currently working with, but it doesn't. So when you open the software, if you know what resin you plan to use, first thing you should do is go into settings, select the resin that you want, maybe take a quick peek at your print settings, make sure nothing looks out of place, and close it. At this point, I'm ready to open up what it is I want to print. So right now I'm interested in this mock-up 2 vanity door. So go ahead and click it, say open. Okay, so you're going to see that the object is blue, save for these edges is red. That's because the file is too big to fit in the XY. So if you kind of hover over this box in the top here, you can kind of get a sense of your working parameters. So what I was attempting to do for the last object is print this a little bit more vertically. I don't want to print it perfectly vertically for a couple reasons. One, this thing is pretty tall, so perfectly vertically it either doesn't fit or it's really close to not fitting. So I need to spin this object on the build plate somehow. So you basically select it, and this is my object list over here in the, sorry again, let me move my little guy here. This over here is the object list that is currently in here, so you can print multiple things at the same time if you decided, well, I want to print this, plus I want to print, one of these guys, then you've got both of them happening in the same print. One nice advantage of this resin style printer is your print time is not tied to your print volume. Your print time is tied to the height of your print. So when we're in here in the settings and you're looking at these exposure times, for every layer it slices of this object, it's making an image of what that cross section looks like, and it's going to take the LCD ultraviolet screen is going to make a picture that looks like that slice, for 8 seconds on every layer, except for the first 5 layers, known as the bottom layers. It is going to have an exposure time of a minute. The reason that we go very high on exposure time for those first few layers is that gives a really solid base connection to the build plate. If you have a weak connection to that build plate, especially when you're starting to go with some very tall objects or large, surface area objects, if you don't have enough exposure time for the bottom, it will fall off at some point during the print and fail, and then you'll have to clean everything up and start over. So now let's get back to this screen. I want to rotate this thing. So the last time what I had done is I kind of put this side towards the bottom and this side towards the top, with this bump out kind of leaning over. So with your object selected, you click over here to this button. It looks like rotate, and then if you're not sure where your X's and Y's are, you can just kind of click these as a reference. So I want to spin this 90 degrees up, like so, and I want to spin this a little bit in that direction. Let's go ahead and spin it just a tiny bit. Let's try like that. Another useful thing to watch is you've got this shadow outline that's going to show you what the total area underneath it looks like. So if you're not kind of paying too close of attention, you'll notice now these edges are getting out of the picture. So I want to back it up a bit. This still looks a little bit outside, and these are right on the edge, so I need to go a little less. Now this is probably about the most extreme angle I could go without risking going off the edge. And at that point you could decide, maybe I'll go 10 degrees and get it a little bit more vertical. Let's go ahead and give that a shot. So now that it's like this, to give you an understanding of what the layers are going to look like, you've got this bar over here. You can drag either the bottom up to kind of look at the bottom section there, or you can drag the top down and look at the section in there. So anytime you're doing that and you're trying to get a sense of what image is going to be created, that's what it is. Another thing to kind of wrap your head around is, this is showing with the build plate on the bottom. As this prints, it's really going to be printing like this. The build plate comes from the top down. So this plate comes down, it makes an image, the material solidifies onto the plate or onto the previous layer that was printed, and then the build plate lifts up. So if you don't have a good contact patch from the build plate to the plastic, or from the last layer to the next layer, you're going to have adhesion failures. Basically the print won't stick to itself and you won't generate that solid object. So in this case, I'm going to start by lifting this part actually up a few millimeters and put kind of a base of supports underneath it. Now the support area is over in here, so all you got to do is click that. Now we still have our object highlighted. You'll see it actually just automatically lifted up, because in my last time I printed, I told it to lift this object 5 millimeters off from the bed. So you can change that to whatever you want. You could try to go very small, but you need a little bit of room for your supports to have a spot to get placed in here. And these settings, I have another file that kind of documents what all of those settings I use are. If you want, you can just pause this video as well and take a look at what I have placed in there. This is for the top of your support, the middle of your support, the bottom of your support, and if you're using a raft, what that looks like. So in this case I'm using none. I almost never use a raft. Probably there's some instances where it could help, but that's not something I found is generally necessary. For the auto support settings, this just kind of has, again, some settings. If you want to know more, I just recommend you to dig more into the manuals of the software on the software website and find out what you want to know. You can do manual support additions, subtractions, and editing. Once you have all of these settings good, just kind of click that all button, and it's going to kind of do an algorithm to try to analyze where supports are needed. And I will definitely tell you that their algorithm leaves something to be desired, but it is usually a pretty good starting point. And sometimes, if the object isn't very complicated, that will be all you need. Now, I will say before I do that if you have a very simple file, let's see, let's go into here, and let's see, one of these blocks I think are simple. So if you have something like this, where it's just a very blocky object, and you again think about each layer adhering to itself, this can be printed with no supports. So in this case, I would grab this block, and I want this to be on the bottom exactly. Now, depending on how this was modeled in the software, this object may be spun in some sort of kind of, let's say, really weird angle, and I'm going to do that on purpose just as a demonstration. Let's say you have this as your starting point. Alright, sorry, I had a momentary pause there. Take a phone call. So, alright, so let's say you've got this relatively simple object and you need to 3D print it, and you really want to have this bottom face be perfectly parallel with this face. And you can try to fool around with spinning this thing, and if you got an object that's in an irregular orientation that you imported, that can get kind of tricky. So you can just click this little flatten by face button while it's selected, and then just go down here and find the face that you want to select. So all of these are just little tessellations on that same bottom face. So you can click on any of those, and now the part is perfectly flat compared to that build plate. And then if you want to get a sense of it printing, you can again use this and slowly drag it up. So what you're looking for is that there's no islands. Like let's say there's an object that kind of came off the side here and up, or something that started up here and connected up higher to the side of it. You know what, I can show you a little bit better what I mean by, I'm going to rotate this to the wrong face here a second. So now if I decided I wanted to print it like this, you might think, yeah, it's all vertical, everything's going to be fine. But here's the problem is where you might run into some problems. These sections are pretty close together, so it's not so much an island, but when you get this all of a sudden and it just closes off, like, watch here, you have a hole, and then you have a perfectly flat spot that all of a sudden just kind of appears, in that image. That one might work, but if you had that as an island over here, there's going to be nothing for it to stick to. It's just going to be creating this image out in thin air. There's nothing for it to attach itself to, because each layer has to attach to the previous layer. Okay, so now I'm going to go ahead and get rid of that just by selecting it, hitting that trash can. And with that in mind, I want to come back here and show you on this part where I think there is a very small example of that issue that comes up. So if we start going, and once I'm doing this movement, I can click the up and down arrows on the keyboard to go layer by layer. You can see this is the distance in, I believe, millimeters that I'm up, and then I'm clicking the down arrow, layer number 41, down, down. Well, this right here, that is what you'd call an island of material, unsupported material. There's nothing for it to stick to. There's no previous layer underneath it. The build plate's pretty far away. So that's what's going to end up happening, is this bit of material is going to get cooked and stuck inside of the resin vat. So there's a reasonable chance that that's going to fail, and then everything above that spot on the print isn't going to work anymore. Now it might, because that's only, looks like, let's see, two layers unconnected. By the time you get to this third one, now that's a big bridge, so I don't think so, but as it starts to connect in here, you might be able to suck that part back off, but chances are it's too late, and this whole area is just going to fail for the rest of the print. And what that will result in is there'll just be a big vertical void there. Now here's another spot. So look at this little snap feature, or this little ramped feature, another unsupported island. That's going to be a problem. So that's not going to generate, or that's not going to stick to the part. It's going to get stuck in the vat. So if we go all the way back up here, now let's go back to where I was a moment ago, which is in these the support settings. So again, right up in here, you just click that. I'm in my support area. It kicked that part up 5 millimeters in Z height because that's what I'd asked it to do. And I'm going to click the All button. That All button is going to automatically generate a platform underneath it and start looking for these unsupported islands and try to find some way to get some support in there. Okay, so what it did for us is it helped this nub, and it helped, looks like, a couple of our spots down in here. It did not support this. Look at that, right? And the other thing that you should think about is, as this is printing, we're pulling, you gotta remember, in a straight Z up and down. So up here and here, you know, this is our image, is those dark spots, those kind of dark blue patches. That's the image that's being generated on the panel, a little LCD screen. So as that image starts shifting over and over and over and over and over and over, you think about how it's going to be pulling straight Z up right here, and then you come down here, there's nothing down here to pull against, so it's going to have a torque load over on these little spots. So there's a good chance that this whole plate is going to flex over and peel off, and again have nothing but print failures while you're going. So what we're going to do is try to correct the problems that I know are here. So I'm going to come down in here, and I'll tell you what, I'm going to leave, just for education purposes of the validation process, I'm going to leave this. Oh no, right, it actually, the algorithm did come in and support that area, so that could be okay. Alright, so then in that case, I'm going to leave this failure in there. I'm not going to correct it, and I'm going to show you how you can find it, because you get some more complicated objects and you're not going to, you know, you can take your best crack at it, but you're probably going to miss something. You know, and it doesn't, and one small miss could be all it takes to have the entire print fail, especially if it's early down in here. So let's go ahead though, and what I know I will do is I'm going to say, to help that Z load issue I was talking about, as this image starts shifting over to the right and there's nothing directly underneath it, I'm just going to peel that up a little bit. I'm going to click on this Add Support button, and I'm going to come in here, and I'm just going to drop some supports in there. All you got to do is click. You can kind of see with that horizontal line where you're looking at, and it gives you a sense of where in the object you're trying to place it. So I'm just going to place a handful of supports across there, and then I'm going to go up, and I'm going to do it again. So in this case, what I do every section of supports is I'm just kind of staggering, more or less, you know, not perfectly, but more or less keeping the same horizontal level and staggering in between the previous ones. Alright, so now I'm going to go up again and just go ahead and keep on adding those supports. And throw another one in here, another one in here, and one out towards the end. Again, now this isn't specifically measured, this is just eyeballing. There is not a way that I know of currently, or a software I know of currently, that can do things like calculate your pull-off forces and figure out where you're going to need all these supports. So it's kind of your best guess and a little bit iterative trial and error. If you take your best shot at it and you find out that it didn't work, you look for where it failed, try to get your head around why it failed there, and try again. So go ahead and pick this up all the way. See how we're doing. We're slowly building that up. So now we're actually going to be using quite a bit of material for this object just out of supports. But sometimes that's what it takes. Now all of these supports will have a little connection nub on here, and depending on how much you care about the aesthetics, you may need to trim and sand those little nubs off to make it look nice. Now if it's just a functional part and if the little bit of appearance issues aren't that big of concern, you can just kind of sometimes just snap these legs off and call it a day. Now we're up in here where this little joint is. I may kind of try to purposefully get a little extra love out on that piece just to make sure that it doesn't have some sort of problem. Okay. Well, this is probably pretty good. I'll pop a couple more in through here just for security's sake, and I'll pop a couple in on that other little leaf spring area of this door. Pardon the kids in the background if you can hear them. We are recording this while working from home. So now I feel like I got it all done except for this one little snap feature that I intentionally left off. So let me pause this recording just a moment. Alright, so now we've intentionally made that failure right in that little zone down in here. And again, I can kind of pop in down in there and you'll be able to zoom in. And you see this little unsupported island. There's nothing around this little chunk right here that's supporting it. So, and there may be a couple other areas of problems, but we just haven't seen. You know, I went pretty quick. I didn't spend a lot of time, you know, focusing on this grip feature that the machine already added supports in automatically. You know, this little thumb grip area. You know, I could spend some time looking close in there and making sure that nothing surprising happens. But I do have this other piece of software that's been pretty valuable to me for kind of checking my work, like I say. So the next thing you need to do, if you think your model is ready, is hit slice. So go over here and hit slice. And this is going to take a little bit of time depending on the complexity of your model and your computer power. Alright, look at that. Through the miracle of editing, you didn't have to see any of that. Alright, so again, you can now see this layer pulled on thing here. The other thing it does for you is this is showing what the image of that layer is going to be on the screen. So if you want, you can spend some time rolling through this and doing the same exercise that we basically did, trying to look for any sort of mysterious shapes that pop up out of nowhere as the layers are progressing. You know, here we got some funky transitions right in that geometry, so we can kind of up, down arrow our way through there. You know, something looks a little goofy right there. I think that's that leaf spring, but I believe that was supported. You know, you can kind of see as we come up right there, the support comes in. Now it looks a little bit actually like right in here, we maybe not quite touching with our support, and we're barely touching anything over here. And again, maybe a similar problem over there. But we do have that building on top of itself below. So let's go ahead and hit save. Now you can see this is saying that we're using Soraya fast actually, but we're not. I think that I have that as an edit that I need to make in my parameter just titles, because I know that we selected the ABS one. So we're going to go back to where we were. I'm going to print this folder and hit save. This is typically, these file sizes can get a little large and a lot to process, so this saving process can take some time. I'll go ahead and pause this recording while we wait for that. Okay, that slice file is now saved. This is also a very good time. Now, we put a lot of time and work into this, and if depending on how much work you're doing, you might want to do this even before this point. But we saved the G code, or which is effectively the G code for the Elegoo Mars printer. It's a different file type, but we do not have the project saved. So if you ever want to open this project again to edit your support structure, or just open it up to spin it around again, you really ought to save the project. So we're going to go ahead and save this in here. I'm just going to save it as a Chitubox file and save. That save is actually relatively fast. If you don't do that, you can open up your kind of slice file that we just saved before this and put it in here, but what that will be different is the supports will not be editable. It will treat that object along with all of the supports as one solid piece of 3D data. So I don't recommend using that as your go-to method, but in a pinch, if you have to, you can go into that model and add supports, but you really can't take them off. Okay, our project is saved, our slice file is saved. Now I was telling you I was going to tell you how to validate that. So we have this other piece of software called Photon File Validator. It's a fairly simple looking thing. All you need to do is click open, find the file that you just made. So that would be this one. We just made that. Click on open, and it is going to run through every single layer and look for discrepancies where some material is not connected to the previous layer. So there's like islands of material that pop up. So it's going to take it some time, again, depending on how big your model is. This model is quite tall, almost 3,000 layers tall. So it's going to let this keep on processing. Alright, and there we go. Now it is going to say if there's a problem. If you see anything in red here, there's a problem. Now the other nice thing about this software is it has in its abilities click the fix button, and if there's anything that's very small, like a lot of these one island pixel problems, it's going to just kind of automatically blend those errors out. So you click on this fix button, it will tell you that you have 19 layers with islands, and you can just click on start. And it's going to go through this and try to figure out what can it do to repair that problem. So anything that says but nothing could be done, sorry, I had to step away from the computer for just a second there. So there's a few of these layers where it says but nothing could be done, and the other one says how many pixels were changed. In the case where nothing could be done, we will have to go in and manually correct those issues if they look significant enough. So click OK, and then at the end here it's going to say what layers have unsupported islands: 253, 274, 351. So at this point I can go back to Chitubox, and we will open that right back up, and we know that we have layer 253. We have a problem, so we'll go there and get right to 253. I'm going to hop back here as well. So if you click this arrow, it will go in that image to where the problem is. So it's saying that that problem exists right down in here. And actually what I think that might be is there's some inscribed text on this object. And let's go try to find that. So it has like kind of like these highlight bars in kind of a reddish color that show you where our issue is, and they're bright red where the unsupported patch is, or the island. So now if I go to 253, which I'm at, and I zoom into that area, lo and behold, here is our little unsupported island. So a lot of times what I'd like to do as well is go just under 250, 251, 52, 53. So you can see that pops up. So I'm going to spin this guy around slowly and carefully, and I am going to try go to supports. Let's see here. Yeah, I'm going to go ahead and try to pop a support in there. Sometimes it's a little tricky to get them in. Now, because this is in that letter and it's on the outside edge of the part, necessary, and in that case I'm not on 253. It was 253 was our issue, correct? 253, and it's right over in that area. It's strange. It's showing there. And this may be what we find as an example of such a small discrepancy in an unimportant area that we might be able to get away with doing nothing. Now let me again, but we're trying to look careful, right? We're using our software. So 240, 41, 42, 43. Now I'm not seeing on 243 a disconnect actually. So that looks, I mean, up in there it looks a little more risky to tell you the truth. What's next? One it says 274. So 274, okay, that's the one that we intentionally left out. That's that snap feature. So let's hop up into that one, which I think we will need to do something about. Okay. And again, if I didn't do anything about this, everything above that failed spot could fail to print. So it's going to compromise the rest of the print job in that part of this LCD screen. So I need to get down to where it just starts to appear. And try to get underneath it with something. Some of these get tricky to pan your way around to. Try not to lose your eye on the ball. There we are. Right? I'm going to try to do one on each side of it. So one there. And one there. Okay. Let's go and spin that back up. Now, that snap has support. Alright, what's there's one more layer that it tells us we had a problem. That was 351. And that is, again, somewhere in this letter area. Something really tiny. Don't think that that one's going to matter. So let's go try to find it, though. Okay, I think it's this little piece, this little sliver right in there. No, that's not it. Let's see, where on our, so it's 1 bump, 2 bumps, 3 bumps, 4 bumps, and a little cavity after the 4th bump. Okay. 1, 2, 3, 4. Oh, yeah. This tiny, tiny little corner. I do not think that that is going to be important. So we're going to go up, 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 up. It's just that little tiny corner of that piece. If we want to try to get in and support that, we can, but with the angle that it's at, I don't think we're going to be able to get support coming in to it. So that one, being that it's on the outside of that leaned face, and it's such a tiny sliver, I'm going to roll the dice on that one. I don't think we're going to have problems with the rest of the print job, even if that tiny little corner did cure to the bottom of the resin vat. Now again, try to keep that in your mind, that as this is printing, it's not coming up from the bottom, it's coming down from the top. So the very first image is going to look like that. That's what's going to be attached to your build plate, and those first 5 layers are going to have that 60-second cure time. So everything up to here has a really tough cure, so it's going to have a really good attachment, hopefully, to our build plate. And then on up we go with our lower ones, and you can just see how this object is going to develop over time. So now we have corrected, let's say, I think the main problem that we had, which is that snap feature. There's a couple tiny islands that I don't think there's anything we can do about, and I don't see them as being significant. Now, if you have some tiny islands and you think that it is going to cause a problem, you may, unfortunately, at that point have to scrap everything you've done, start with just the model again, and start changing the orientation in a way that will be able to avoid having that island of material. So it can, some objects are pretty tough to orient. There are sometimes some objects I've brought in and I just can't figure out a good way, period. The design of it is such that it just doesn't lend itself to 3D printing very easily. So now that we have the problem solved, I think we are going to, again, hit the slice button, re-slice it, and I'll slice. There we are, finally kicking that off. Pause the recording here so you don't have to wait. Alright, slicing process completed. I'm not expecting to do much analysis here. Now, I didn't really talk about it before, but you do have this summary over the side where it tells you your machine name, your resin name, which I mentioned before that I need to correct that. That's the incorrect name of the resin. How many milliliters of resin you should expect to use, how much the mass of the end product is going to be. Well, I should say the mass of everything, including supports. The mass of your actual object will be different. But how much you're going to spend in material to do the printing and how long it's going to take to do the printing. So let's go ahead and hit save. And I'm going to go ahead and overwrite that original file because I'm not interested in keeping that file. Again, this is a saving process, can take quite a long time, so I'll pause the recording right here. Okay, now that the file is saved, we're going to go back through and use Photon File Validator to open that same file. Mockup number 2, just saved a moment ago. Let's see, hold on, did I save that in a different folder? Yes, I did. I accidentally saved it here. So that one's the later one. And I'll click on open. And now we will validate again. It's going to find all of the same errors that it found before, minus the error that we corrected. So by the time that this validation and fixing process takes place, we should end up only with those 2 little tiny errors on the letters on the side face of the part having a problem. And let's just make sure of that. And once we confirm that that's the case, we'll save the file that results from this software and be able to use that file right in the printer. So even though it's quite a few layers, this this software does a pretty good job of repairing them quickly. So again, we found now 17 islands. Start the repair process. You're going to see a couple of, but nothing could be done. No, only the one this time. Great. So click OK. And let's just take a look at that 351 and confirm. Okay, it's only that little spot right in here. And you can, in this software, if you want as well, preview the 3D of where we're talking about. Alright, so now that we have what we think is going to be good for the printer, I'll go ahead and click Save. And what it does is it just takes the exact same file name you had, saves it in the exact same location, and makes a -1 or a -2 after, depending on how many times you iterate through this. It's just noting all of your other parameters, right? So that you could change some parameters in this file as well, or using this software. If you already know that you have a good slice, but you want to increase your exposure time from 8 to 9 or something like that, you could just open it up with Photon File Validator, resave it as a new file, and just change your parameters here. So click OK. And this software, for whatever reason, also does a much faster job than Chitubox at saving it. So let's go into where it was, and this is the one that mockup -1. This is the one that we just saved, so I'm going to go ahead and cut that out of there and put that into the print this. And I don't want these slice files, so I'm going to go ahead and just delete those so that I don't make a mistake. Now these are what you would save onto the flash drive that connects to the Elegoo Mars machine, and in the Elegoo Mars itself, navigate your way to that file, select it, click print. Setting up and operating the printer itself is, again, kind of another topic of training, something that you can probably figure out by reading the printer manual itself or watching a couple of YouTube videos on tutorials for running the Elegoo Mars. I hope that this has been helpful in you figuring out how to set up a file so that you can make it actually print, and I hope you have as much fun with it as I did. Enjoy.